Happy Friday, ESRS. Today I have the pleasure of speaking with Jari Gool, the winner of the 2022 Daytime Sleepiness Award Young Investigator Award and the ESRS Early Career Research Award, to learn more about the amazing work he's been doing and plans to do with these awards. Yari, thanks so much for being here and congratulations on these two very exciting awards.
Thank you very much, Jen. I'm happy to be here.
Awesome. So Yari, the work you're doing on hypersomnolence is so important, especially for individuals who struggle with narcolepsy. So can you tell us a little bit about yourself and how you became interested in this work?
Of course. So I'm currently an MD PhD student located in the Netherlands, where I work at Sleep-Wake Center Sein in Heemstede, which is a specialized sleep clinic, but also at the Amsterdam UMC in the anatomy department. And I work together a lot with people from Montreal at Concordia University, where I focus a lot on hypersomnolence disorders in general. And I use different methods to study these disorders. So a lot of it is about neuroimaging, MRI and EEG in particular, I think, which we'll talk about a bit later as well, but also more epidemiological studies, machine learning analyses in that direction.
That's awesome. So the Daytime Sleepiness Award was based on your work in neuroimaging, like you're speaking about, in narcolepsy and idiopathic hypersomnia. So for these analyses, you used combined EEG fMRI recordings. Tell us a little bit about why you chose to combine these methods and what you think we can learn from it.
These methods, both are quite powerful neuroimaging techniques, but they capture a different thing. So EEG, I think we all know, we use it a lot for sleep-wake scoring in principle, and it has a great temporal resolution in general. Whereas MRI, which I'm also using, functional MRI, it has a better spatial resolution. So if we're able to combine these two things, we can learn a lot from sleep-wake disorders, especially if we try to have people sleep within the MRI scanner. So then we can use the EEG to reliably identify all the different sleep stages and the MRI to look into the brain activity patterns. And from these patients, we know that they have a troubled sleep architecture. So when they fall asleep, the people with narcolepsy, they very easily enter REM sleep. And this is something where we know very little about how this happens and why this actually happens. And with this study, this is one of our goals. So we really want to see what actually happens in the brains of these people with a hypersomnolence disorder and disentangle why they are so sleepy during the day with resting state scans, for instance, but also have them nap in the scanner to identify the neurocorrelates of these different sleep phases.
Do patients have trouble falling asleep in the scanner?
Not so much. So these patients, they are super sleepy. So during the napping test to get the diagnosis, they have to fall asleep within 8 minutes on average. So that really helps them also in the scanner, even though of course, it makes a loud noise and it can be a bit uncomfortable being stuck with your head in the scanner with an EEG cap. But in reality, most of them, they even trouble to stay awake during the cognitive tasks that we also have them perform. And it's fairly easy for them to fall asleep during the napping scan. The healthy controls, on the other hand, that's more challenging because we need people that are quite familiar with the scanner. And we also acutely sleep deprive them before they come to us to really have a good chance of them actually falling asleep in the scanner.
Great, that makes a lot of sense. So it's such an interesting concept that you have, because we don't really consider using neuroimaging in the diagnostic differential for other sleep disorders. So how did you come to consider that neuroimaging could be a useful tool in that population?
I think we're not there yet to actually use it as a diagnostic measure directly. I think we first can learn a lot from it on a biomarker side. So we really need to understand these disorders better, especially narcolepsy type 2 and idiopathic hypersomnia, where we hardly have any clue what's going on or what's actually causing these symptoms in these patients. So that is one of the important reasons why we're conducting this research, to really find those new biomarkers and also compare it with people with narcolepsy type 1, for instance. And from that perspective, we will be able to hopefully identify biomarkers that maybe eventually can be used in the diagnostic process. But we're looking into more advanced analyses where we take the whole brain and then compare that between the different forms of hypersomnolence disorders and see if we can use basically the whole brain profile as a diagnostic measure. But that's something more for the future.
Great. So that actually brings me to my next question. So the Early Career Researcher Award that you won was awarded for this very interesting article that you published in 2022. And in it, you discussed using an extensive spectrum of complaints and measures to disentangle hypersomnolence diagnoses. So for our listeners who have not yet had the opportunity to read your paper, what did you conclude?
I'll be happy to explain more. So what we did is for this study, we made use of the European Narcolepsy Network database. And this is a very large collaboration between more than 20 sleep-wake clinics spread around Europe, where they all combine the same symptoms or measures on symptoms, but also on sleep tests or diagnostic measures, like the lumbar puncture, the hypocretin levels, or the HLA type. So it's a very diverse set of measures that we have. And what we did is we used an unsupervised machine learning algorithm to identify subgroups for us. So we blinded the algorithm for the current diagnosis that the people have right now, and we let it look for reliable subgroups within the whole population of people with a hypersomnolence disorder. And there it was able to identify different subtypes of narcolepsy type 1. So that's it basically, it enhanced what we know about that diagnosis, that these people are hypocretin deficient, but it made a differentiation between the people with narcolepsy type 2 and idiopathic hypersomnia that didn't align with the current diagnostic criteria that we have. And we're currently getting more and more clues that these current diagnostic criteria, actually, they should be reconsidered, or we should find new, better biomarkers. And we believe we made a little step into this direction where it did find reliable biomarkers, but then based on other symptoms. And the most important one was the presence of sleep drunkenness. So we think we should really look more into the phenotypes of these patients and really try to identify whether they have a particular set of symptoms that some of the other groups don't have. And the sleep drunkenness, but also the prolonged sleep duration that we saw in one of those two subgroups really provides important new clues or avenues to pursue.
That's so exciting. I'm so excited to hear about how this work is going to go. So Yari, now that you've won these awards, what research projects are you planning and what aspects of the work are you most excited about?
So far, personally, I really enjoyed working in such large collaborations because I feel like you finally have enough data to really look into the more detailed analyses that you could do. So this is something I'm actively pursuing now to continue this. So both with the European Narcolepsy Network, we're looking into incidence rate analyses because we know, for instance, that narcolepsy type 1, that it can be triggered, and we think it's immune related, the onset of the disease. And we're looking now whether there are certain triggers that we can identify that can trigger the onset of narcolepsy type 1 outside of the ones of the H1N1 pandemic that we already know. So that's one avenue. And for the neuroimaging, actually, we're currently setting up a global consortium on neuroimaging. And we're asking everybody basically who has MRI scans available across the globe on people with a hypersomnolence disorder to reach out to us, because we already have more than 20 sites that are willing to analyze these scans in a harmonized way. So instead of having a study with maybe 50 or maybe 100 participants, we can reach 1,000 people with narcolepsy or idiopathic hypersomnia to really be able to better look into what is happening in the brains of these people.
That's awesome. I'm really looking forward to hearing about your findings that are coming up. So Yari, I want to thank you so much for being with us and sharing your fascinating and impactful research. And congratulations again on both of these amazing awards.
Thank you, Jen.